everyone. My name is Sean Sadler. I'm delighted to welcome you to another installment in CODA's webinar series in which we highlight some of the key challenges out there in the decommissioning space and some of the cutting edge solutions and services that are available to meet those challenges. Now, conducting operations in the subsea environment is obviously an integral part of offshore decommissioning activity, but it's also one of the most sensitive and risk-prone areas that the industry needs to deal with. It's an activity which is likely to attract significant and broad-based attention, particularly when you're working right at the interface between subsea infrastructure and the seabed environment. But that's a challenge that's seen our guests today from CODA partner Rotech Subsea effectively managing risk and delivering the best possible environmental outcomes in decommissioning operations worldwide. I'm therefore delighted to welcome Bill Hare, Rotech's business development consultant, to formally introduce our speaker for today's presentation on deburial of subsea structures, pipelines, and umbilicals. And also to remind everyone throughout the presentation, drop your questions into the meeting chat or into the Q&A box as we go along. Please remember to do that. For now, I'm going to say welcome, Bill. And it's over to you.
Wonderful. Thank you, Sean, and delighted you can all join us. And yes, I'm looking after Rotech Subsea's business development here in Australia. Now, Steve and I will be both over in Perth in a couple of weeks' time to attend the EXA conference, and we'll have a stand at the event. Steve, we're sponsoring the golf day. We're hosting a sundowner as well at Print Hall with featuring Jerry Fraser, shucking some oysters. So make sure if you can come along to that to let us know, and we'll swing you an invite. And also on the final night of EXA, you can probably find Steve shouting some tequila slammers at Joe's Juice Joint. So that is both an invitation and a warning. So I'm really delighted Steve can join us. So handing over to the Global Director of Rotech Subsea, Aberdeen-based, Steve Cochrane.
Thank you, Bill. Good morning, good afternoon, good evening, ladies and gentlemen. I'm calling in today from Aberdeen in Scotland, so it's an early start for myself. Some of you will probably have just a t-shirt on. I've got a t-shirt and body warmer on. So I will share my screen now, and hopefully you can see my paper. This will last about half an hour today, and I want to give an overview of Rotech Subsea, which is a technology-driven company which offer global subsea solutions, and we've been operating for about 30 years in the market. A little bit about me: I've been in the industry for 20 years. I joined Rotech Subsea in 2008 after working offshore, and I helped set up the new business in 2015, and I was involved in the management buyout of Rotech in 2016. And I managed the business development, commercial, and the growth of the company at Rotech Subsea. Today I'm going to talk about what we can offer in decommissioning. This page shows a kind of overview, life cycle of what Rotech Subsea can offer as a whole, from pre-commissioning, sand wave leveling, root clearance, debris removal, through to the commissioning, trenching of cable, pipeline, fibre optics, interconnectors, cable repair, IRM, deburial, pipeline deburial, access, cutting, which comes in nicely to our decommissioning offering. I'm going to show you a little video just to show you the system, and I think this helps you understand a lot of what Rotech do just from this clip, which I'll let you watch just now. Okay, so Rotech in the decommissioning world have carried out over 75 projects globally for over 45 clients in 10 different countries. So we got a great track record and experience from Europe, America to bring down to Australia. Just a little bit about who we are. So Rotech Subsea have the support from our sister company, Rotech Engineering, who are our research and development company. They manufacture, design, build and operate these tools that I'm about to show you today. We're the only company that have a dedicated internal business that build, design and operate for the Rotech Subsea company. It's all one, but how we treat it internally is two companies. So Rotech Subsea provide the tooling, the service, personnel to operate projects globally. Headquartered in Aberdeen, we have a business in operation in Taiwan, and we have a business in operation in America. We've been building, design, operating systems since 1994, right through to today, constantly evolving the technology. As I say, we build, design these systems, and we've built and operated tools and tailored systems for different applications. Some of you may know of Rotech Subsea. Some of you may know that Rotech was once a mass flow excavation company. Some of you may still think that Rotech is a mass flow excavation company, but the technology has differed tremendously in the last sort of 10 years from the Rotech next generation tooling. In 2012-15, through a 3-year R&D period, we designed new RS technology, which gave us the advantages over the old mass flow technology, where new fluid dynamics software, lessons learned from internal projects, personnel, engineers, were all involved in designing the new technology to increase the jet pressures, to reduce that flow, to reduce that environmental impact on the seabed, and to create an operation that was much faster to increase productivity, to reduce day rates. We have a twin system as well for accuracy in that flow to penetrate the subsea, to debury the asset quicker, more efficiently. So there's many advantages in new technology compared to the original mass flow tooling, which I will cover as these slides unfold. Our excavator landscape, these new systems have a much higher jet pressure and lower flow. As I mentioned earlier, this is very advantageous in reducing the environmental impact. The older mass flow systems were very, very high volume, jetting out over 8,000 litres of water per second. These new systems have been reduced dramatically to 300, 400 litres per second, up to the 8,000 litres if needed, but generally because of the higher jet pressure, we're able now to offer less flow, higher jet pressure to the seabed, reducing the seabed footprint, excavating and creating areas narrower, deeper, giving a more refined trench width, deburial width, seabed pit width for cutting and removal. We have a wide range of tools now, which I'm going to show you. So we've carried out over 600 projects worldwide. We have over 32 systems and we've over 90 employees, and we're offering a full life cycle solution through to the decommissioning. Yes. We have single systems for excavating. We've twin systems for increased productivity, and we've hybrid systems to cope with different soils from soft through to very hard materials. We've also got our recovery grab systems for cutting cable, removing cable, removing pipeline, and removing large boulders. It's a non-contact method that we use on the excavation deburial for access, for allowing the cutting and removal of structures or pipe. It's biodegradable oil, it's environmentally friendly. And as I mentioned, it's a lower environmental impact now than before. So I'm not going to go into too much detail today on the specific tools. We've over 17 different configurations. Depending on the scope of work, the soils, we will provide you the correct tooling. Now this gives you an overview of different systems quickly to show you that we are not just offering one tool, one solution for the campaign. We'll pick the right dedicated tooling for the scope of work, whether it be hybrids, singles, twins, etc. When we're excavating, when we're operating subsea, typically we operate about 1 metre to 2 metres standoff from the seabed or the pipeline or in and around the structure. The visibility down there, we have to use to see what we do. We use a Gemini sonar system. This allows us, you can see here, a sonar profile of the width and depth of this trench when we were debudding an umbilical with this tool. This sonar system is placed on the rear side of the tool, so we're able to see down the trench. We can see in real time the soils fluidizing, dispersing away as we create access for the umbilical cut and removal. Not like the older mass flow type tools where you would have a very wide channel to excavate and debody a cable, pipeline, umbilical, etc. So very narrow, uniformed trench profile here. And we see what we do by using this Gemini system. So some case studies now of what we've been carrying out globally. This was a campaign for Maersk, ultimately for Perenco. We had to debody and backfill a jacket template. Yes. This campaign was carried out in the North Sea. We had to recover and retrieve structural framework. We were operating in water depths around 15 to 40 meters water depth. We were working in soil conditions that were very loose to very dense sands. We used our TRS-2 system, which is our larger system, to debody. The jacket was excavated in around about 4 passes, vertically and horizontally, to give access to allow for the cutting. We had to create box sections around the main structures, around about 6, 10 to 5 meters in depth boxes. We had to excavate around this structure, and the Rotech Subsea grab removal tool was used to relocate different pled components. Yes. This here was a campaign we operated for Wintershall, where we were required to debody and give access for a 14-inch pipeline in the Danish sector using the TRS-1. We debodied in water depths around about 45 meters. TRS-1 is a twin system that's slightly smaller than the TRS-2. This, as I mentioned earlier, was selected to reduce the environmental impact. As it was a smaller pipeline, we went for a smaller type tool to expose and debody this pipeline, which was 1 meter below seabed material. This was conducted in 1 to 2 passes. This operation was very quick to debody. Yes. This was a campaign we carried out for Deep Ocean on the Thames, Bacton. This is a 24-inch gas pipeline. We debodied, I think it was approximately 80 to 100 meters of pipeline. 3 spot excavations were created to allow for cutting and removal, and the pipeline was debodied at around about 0.7 top mean seabed level. So this campaign was carried out in Scotland using our TRS-1LD excavator, along with our boulder grab, where we had to remove rock bags and different debris material. Some mats as well were recovered from this operation. We had to expose and debody sections of 300-meter pipeline to a depth of 2.7 meters. Yeah. With very soft, silty sands. Yes. This was a campaign where we operated for VBMS, which is now part of the Boskalis company, where we had to debody umbilical. Yeah. A very quick campaign this for us. We selected our TRS-1 tool, which has the capability of cutting soils up to around about 80 kPa. This tooling had the ability to cut these conditions, which are around about 60 kPa. Yes. This campaign was with Boskalis, where we had quite a lot of rock dump to remove, which was positioned over umbilical. Before we debodied the umbilical, we had to remove and disperse rock, which was at a depth of 1.2 meters top of umbilical, and we had to remove 12 to 15 inches in diameter of rock armour in water depths of around about 40 to 45 meters water depth. Yes. Yeah, the TRS2 system, and just talk about the benefits now. So it's a higher volume system, but it's a very controlled system. It can operate as shallow as 1.5 meter up to around about 300 meter water depth. It's diesel driven with hydraulics. This is our most powerful system in the market, which is desirable for the vertical and horizontal access in and around structures, which you saw on the animation earlier, which we carry out more regularly. Yes, yes. These tools can actually operate at a 10-12 meter standoff distance in vertical mode, which gives you access vertically through structures. And when we're operating around the structure, once we've excavated vertically, as you've seen, we switch these heads to horizontal, which allows us to access, creating access in and around structures for the cutting and removal. Give you an idea of scale of pipeline, we've lowered deburied pipeline up to 48-inch. These tools can actually cope with 60-inch. We carried out a campaign for Saipem where we had to lower two 48-inch pipes to 1 meter top. We averaged around about 3 meters per minute. And I think it was 2 to 3 kilometers of pipe that we had to lower for Saipem. The twin system is ideal. As you can see here, allows us to straddle the large pipelines to allow the flow to excavate beneath and around the pipeline to debury or to lower the asset. So one of the methods that we have is that if the pipeline is going to be left, we can lower the pipeline in further into the seabed to avoid snagging, etc. on for the fishery side of things. Yes. We can also offer backfill, so these tools can be deployed where the heads are positioned horizontally, angled in, where we can collapse and push debris back in to a pit that we've opened up for deburial. Yes. These tools, I'm saying, are very powerful. It's very controllable. Our hydraulic power units, diesel engines, these hydraulic systems have been purpose-built for these scopes of work where the power delivery is very linear, it's instantaneous. So when we're deburying material, rock armor, it's dispersing away in a controlled fashion. We're not blasting large columns of water to the seabed. Here, just to give you an idea of rock displacement, we've actually moved and rolled rock up to 0.7 of a meter out of the way on the seabed. Anything larger, we would use our boulder grab removal tools to remove large rock armor. Yeah. On the large scale, just to show you the capabilities over in the Gulf of Mexico or Gulf of America, we actually have excavated to depths of 17 meters with these systems. For instance, this one was to remove a jacket. Had been toppled over. We had to excavate to the base of that. Here's another over in the west for Chevron, where we had a toppled jacket. We had to get down and cut these conductors. We were working in excavation depths of between 10 to 15 meters in depth. We had to create a diameter here of 70 meters and remove over 50 cubic meters of material, which is a large amount of material. So on a large scale, we can use these larger, higher flow systems at full capability to give you a large area to cut and remove. But I know down in Australia, the environmental impact is of great concern. So we've, as I showed you with different tooling from singles to twins to hybrids, we can select different systems to reduce that environmental impact to give you more of a reduced deburial. Yes. So one of the activities that Rotech are carrying out regularly is cable removal, cable repair, umbilical cutting, removal, repair. We have these new single and twin grabs where once we've deburied the asset, these systems are deployed down to pick up, and we can cut through with this mechanism, a guillotine mechanism on the grab. We can cut up to 330 mil with the standard guillotine cut on this grab for cable umbilical export, which can be seen here with a company called NC over in Europe, where we had to debury using the TRS-2. The reason we used the TRS-2, which is our larger system, is that umbilical was actually buried at 4 meters in depth. So we needed the volume and the jet pressure to get access to that umbilical to then go down with a Rotech Subsea cable grab, lock onto the umbilical, cut and remove the sections to repair. Anything larger, we would work with partners for large pipeline cuts, etc. We've got this is one company that we've got a good partnership with, Decommissioning, who I'm sure some of you are familiar with down in Australia. They've got the ability to cut up to 48-inch. So once we would debury, they would go down and cut those sections. For larger boulders, which we carried out various campaigns for, like Subsea 7, Seabed 7, and various other companies, this grab has a ability to open up to 3.7 meters. So we can pick up large boulders, 15 ton is the capacity. We've different grabs depending on different sizes of material. So anything that we can't excavate, debury or fluidize or redistribute through the excavation of the RS1-2's different systems that I've showed, we would physically remove these with the boulder grab system. So how our tooling is made up, as I mentioned earlier, we provide the team to operate 24 hours. Sorry, my slides are jumping. We provide the tooling, our engineering team. Once we receive the data from the client, once we get the geotechnical data, the structural information, we will provide the right tool for the campaign. 17 different configurations, as I mentioned earlier. It's all driven from the hydraulic power unit, and we have a hydraulic umbilical winch which feeds the tool. As I mentioned, these systems can operate as shallow as 1.5 meters to 300 meters water depth. We deploy from the ship's crane or the ship's A-frame. We operate from vessel moves. We can gain access, very close access to structures, depending on the vessel and the vessel type. Once we get the vertical access from the deployment, the tool is very stable in the water. These systems are gyroscopically stable, so they're positioned by winches and tuggers on the deployment method, subsea, and they're very stable. As mentioned earlier, we have a sonar system on these tools that allow us to see the seabed width and depth. Give you an idea of the footprint, we don't need large vessels to operate. And that, again, with smaller vessels, reduces the environmental impact. We operate through multi-cats, barges, right through to DP2, DP3 ships. This scope on the left was a campaign in Europe where that barge was assembled purely just for the Rotech tooling. You can see the small footprint there, which is a reduced environmental impact compared to a vessel on the right, where typically we would operate more on for larger, bigger campaigns. So we can tailor the tooling depending on the vessel and the campaign. So that was a quick 20-25 minutes on an overview of Rotech Subsea. We believe with our capabilities and track record that we can bring our expertise, knowledge down to Australia to save on costs, efficiency, and bring our expertise down from our global experience throughout the Europe and American market. And I'd like to thank you all today, and hopefully there's some questions. If there's anything specific you'd like to ask, my email's there. I know some people may not have the time to stay on, or they want to ask something specifically. Please email me and we'll get back to you if there's anything that you wish to discuss further other than speaking about it today. So I'll hand you back to Sean now. I appreciate that opportunity.
All right, thank you very much indeed, Stephen. delighted to see we've got well over 50 people on this call, so please do get your questions in for Stephen while he's here. While we're waiting for people to fill that up, Stephen, I wonder if it'd be a good time for you just to talk a little bit about Rotech's recent experience of operating in Australia, because you do have that experience. So if you can just outline that for people, I think that'd be a really useful piece.
Yes. Okay, thanks, Sean. Yeah, we carried out a campaign. This is one that actually really we're proud of. We've done various campaigns in Australia, but one we're really proud of was that we carried out a post-trenching umbilical campaign for Subsea 7 for ESSO on West Barracuda. Yeah, it was several years ago. It was 2020, 2021, but that was through COVID, and it was a period where we had to excavate, mobilise and carry out operations from Aberdeen, from the beach side in Aberdeen, the time difference, etc. And we mobilised our crew, our personnel, all from equipment, all from Aberdeen, and that campaign went very well. Subsea 7 actually used it internally as a case study. That campaign we had to excavate, I think it was 4 or 5 kilometres of umbilical trenching, and it was a proud moment for Rotech to do. You can imagine a company from Aberdeen operating in Australia is hard enough, but to do it through COVID, it was, and we got a good track record with Subsea 7, and ultimately from that we worked with their partner CMA 7 from that period, and we're still working with CMA 7, but it was through that campaign that we gained that trust in Subsea 7.
Very good. We have had a very interesting question come in for you, Stephen. Australia is well known for its extensive calcareous sand deposits, which vary from loose to highly cemented formations. Has your jetting tool been used in these conditions, particularly in Australian waters? And if so, how effective is jetting in breaking down cemented formations? And what pressure and flow rates have proven most successful?
Okay, so I'd answer that by saying we haven't had experience in Australia, but we have had experience in the Middle East working for Saudi Aramco in similar conditions, where we actually did break through cochrane material. These systems now would be known as the RS3 tool that we would deploy for the really hard material. That has a capability of breaking through approximately 330 to 340 kPa.
One of the things that I had as well was you talked about a fairly exceptional operation of excavating something like 17 meters. Can you give an idea of how long that took, even though it was over a restricted area, to actually do that type of operation?
That one, I need to check the exact hours, Sean, but I think that one in particular took us about 3 or 4 days to do. They did use toil pumps at the base just to suck and remove some material that had collapsed into that pit, but we were still used to flush out the material that had dispersed and come back into the pit. But I think it was roughly about 3 or 4 operational days that we took to do that campaign.
Now I know that there was material on the slides that covered some of this. And there were quite a few different references to water depth range. Can you give an idea of, typical depth ranges, water depth ranges of which you operate, and what the limits are for some of these tools?
Yeah. Okay. So we built systems that are ultra shallow. They're called our LD tools for low draft. So we can operate these tools in as low as 1.5 meters water depth. Standards for these tools are around about 300, but typically our average operations are ranging from around about 10 meters to 150 meters.
Thanks, Stephen. Another question has come in. Has the rock removal tech been used on CGS structures, skirt removal?
I believe it has. I need to double check. We've got various track records, so I need to check that, but I believe it has. That's one where I'd like that particular person to email me if they could, and I'll get back to them on that. I'd need to double check with what reference I'm thinking about.
The only other thing from me, Stephen, was really around some very general thoughts around. I talked in the beginning in the introduction about managing risk. How do you characterize the biggest risk associated with these types of operations, and from what aspect would you see that, and how does the Rotech system help to mitigate that?
Yes. Okay. Yes. Well, first of all, if Rotech believed there's a risk, we wouldn't carry the project out, or we wouldn't propose ourselves. If the method wasn't right and there's a risk in that, we would withdraw from the process. Risk in terms of these systems operating, we've got a very, very, and we're proud of it, good track record of operations in terms of carrying out projects and safety and the management and the maintenance of these systems. We operate, as I say, about 1 metre to 2 metre standoff distance from the structures, the pipeline umbilicals, the seabed. So we never come into contact with the seabed, other than if we are physically picking the asset up with our grabs. But the risk side of things, we take very seriously, and we weigh up the campaign if we want to carry it out or not. And we very rarely take on any unknowns. Sean.
Another question has come in. What sort of soil geotech information do you need? What types of data and information do you need to be made available to you before you can plan and execute these types of operation?
Yeah, normally we get through our request for quotations or material from the client is core samples, so CPT data. And the reason we've provided a solution known as the hybrid tool is that all the geotech guys will know if there's any geotech in here, and I'm not a geotechnical person, so I'm talking in layman terms, but when we're excavating, we come across pockets of very, very soft material and then pockets of very, very hard material. So we've now been able to offer through the hybrid solution our RS3 jet, which cuts very, very hard material, and our RS1 or RS2 in the same headed frame, so that we're able to cope with different soils along. But the route, and that can go from depth to along the route. But I would say that as long as we've got a general geotech CPT data, and we will work and we'll speak to the client and request any more seabed material if we need to, if we're unsure of what solution to provide.
Again, just a thought from myself, really. I mean, you talked a little bit about experience of working in Australia. What do you think the future holds for Australia in terms of the amount of deburial or even reburial activity associated with decommissioning over the next few years? Is this, do Rotech look at this and see as a big viable market?
Yes, glad you brought that up, Sean. I mean, that's one of the reasons we've started to invest in Australia. We brought Bill on now, who's looking at the market, and we see a big opportunity for Rotech. We're a company that have looked at Australia in the last 12 to 18 months, and we're making plans to put equipment in country, service and mobilise potentially from Perth. Looking at the research and development of the market, it excites Rotech so much so that this year we're going to make some big moves into the industry down there, and we will be active and planning ahead for the market, given what we see and what we know and what we can bring down to Australia with, as I mentioned earlier, the knowledge, expertise, the equipment, the track record that we're able to bring and help companies such as we see here today.
Yeah, it's good to hear. And of course, one of the keys to sort of establishing a foothold in this part of the world is having somebody on the ground, somebody you can pick up the phone and talk to. And of course, you're working with Bill, who's fairly well known in this environment already. And clearly, as I say, you're going to be at EXA and well represented at EXA, and opening the doors for people to come in and talk to you at that time.
That's right. Yeah, we're going to exhibit at EXA. Bill's working hard behind the scenes to get the plans put in place. It's just a few weeks away. We're quite excited about it. Looking forward to coming down. And there's quite a lot in the, no pun intended, in the pipeline in terms of opportunities. We're seeing a lot of tenders coming in. A lot of people are really interested in this equipment and the track record that we can bring down. So I'm looking forward to this event along with along with Bill.
That's good. Listen, we have had another question come in. It's it's a fairly specific one. Thank you, Mark, for putting these up. Have you looked at what marine growth is removed by your tools?
Yes. Probably one from engineering operations to answer. I know after every project that we do, we look at things internally, lessons learned, etc., and look at what we've actually carried out. I'd have to speak to our engineering team with that one to get back to Mark. I wouldn't be able to answer accurately on that one, unfortunately.
Remains for me to thank everyone for your attention and participation today. It's been, and thank you very much indeed to Stephen from Rotech Subsea and Bill, who's the Australian business development consultant. Really appreciate you taking the time to share with us insights into what your tools do and your interest in the Australian market. Is there any last words from yourself, Bill, on that one?
No, look, thanks very much, Sean, to you and the team. And yeah, we certainly look forward to catching up with everyone at the EXA conference in Perth. We'll be there from the 10th through to the 14th of March.
All right. Thank you very much indeed, everyone. Really hope you got something out of the sessions today. And thank you for your questions. Much appreciated. Bye-bye.
Thank you.
Thanks very much, guys, for giving up your time. Thank you.